Most of what I do is product design for acoustic treatment in mostly like large office spaces. So I'm working at a newer, smaller company that's very understaffed. So I started leaning on Grasshopper to do the work of interns. Um, so sometimes I'll do like custom walls and all super algorithmic design, but a lot of what I'm interested in is just how do I automate processes and kind of give myself little red flags so I don't make something bigger than my material sheets are or something. So what we're looking at here, this is basically, you guys know what PET felt is? It's just like a squishy absorbent felt that we cut with a drag knife. So a lot of the stuff I make is just directly just goes into DXF files so that the drag knife can just read it. So this is a folded piece, and I've got these double lines, which are like a V groove, so I can kind of fold stuff up in like an origami way. So this is just a simple one I made. Got to have, this isn't showing it, but there's some hardware attachments. So I just set one line in the x-axis and then 3 here. And these ones later allow me to assign hardware attachments. And then if I did an array of these, we can have this notch pop out. And so the, let's see. Oh. Basically this one, I can just move this part around and it follows just a cosine function so that I can have like an array of baffles in a ceiling swell and undulate. And I can just move this center line. And the reason I did a cosine function is because these edges pop out on the corners more when it's deepest. So I wanted that to kind of reduce as I get towards the end, because otherwise I would be running off a sheet of material. So let's see. So if this blue line represented my material, I wouldn't want those corners to fall off. Let's see. So you can see them splaying out. So this one might be kind of hard to look at just because it's a cut file, not an actual product. So let me pull up another thing.
Yeah, do you have a picture of what that turns into and when it's cut and then?
I do.
I'm imagining it's sort of like a shell or something that.
Yeah. Let me pull that up.
How thick is that felt you're cutting with the drag knife?
We've got a 1/2 inch and a 1 inch material.
1 inch, wow.
Yeah. It's pretty rigid.
That's a big drag knife too.
Yeah, we've got we're getting some zones which are just better. The one we use now oscillates though, so that helps. So here's just a quick 5-minute rendering. So that notch here, that's what's moving around, and it's just pieces that fold up. Keep getting people who want stuff to look like wood, so I'm like, all right, we can print on it, and then you've got an edge condition. So I've got another product where the edges wrap around and fold in on itself, so you don't have that exposed edge. But a lot of the stuff, like designers are like, yeah, but can I get it with this? And it's like, do you want to pay for it? And they're, so we'll see what your contractor comes back with. So let me do another one here.
Yeah, while you're doing that, it just makes me think it's a classic designer comment, because I'll be looking through and all sorts of products. It's like, well, can I get it looking like that, but that finish and this thing? Can we just like merge all those together? Why can't I have that?
It's always like, I saw a circle and I saw a square. Can I have one that's a circle and a square?
Yeah.
So this one's like my bread and butter scripts. So I can just array any spacing and hardware locations. So these are a bunch of tabs that fold up that index on the cut file. And I've got a quarter 20 threaded coupler, and it lets me locate that. So if I've got some weird structure that like meanders for whatever HVAC reason, I can get that to align on each baffle differently. And then it indexes them with a number. And then let's go to this view. So this one, so if I can get a quick image to a client out, it makes a 3D model of it as well for preview. And then I can change parameters based on like my material efficiency. So this is average is 11.5 inches, and then I can make them shorter. And these are just kind of standard sizes. And a little bit hard to see in this view, but these will undulate. So I've got a pattern, so these follow that. Sometimes people just want a totally random organic thing, so I just randomize them. And then we've got a couple different profiles, so I can do oops, that did not work. Let's see. What have I broken here?
It always happens. No live coding. Isn't there a rule?
Anyway, so I can do like a smooth one.
And these patterns repeat, or do they, or you can just make whatever, like if somebody has a cafeteria that they want everything happening, they can do that.
So they repeat unless I mess that up. Go back. Okay, so
is the amplitude too high?
What was that?
Is the amplitude too high? I was just wondering if pulling that down.
That shouldn't be an issue. So you can see that this pattern goes on. So let's start and make more. The 3D aspect makes this run super slow. Actually turn that off.
It's interesting you're making the 3D thing out of the 2D thing, it seems, rather than the 2D thing out of the 3D thing.
Yep.
Yeah, it's funny. Yeah.
I mean, it's cool because you're just doing a really simple layout that might be on a ceiling or something, right? And then Grasshopper's doing all the rest for you. Yeah.
I can just take an RCP and just drop this in. And then, I mean, if you want a quick dog and pony show with a client, I can just pop their RCP in, extrude their walls down, and be like, here's what we're talking about. Let me clear out these. So it's kind of funny. I used to work for a different company, and someone else did the scripting, and they made it to keep the order. You had to like click each row in the correct order. And I was like, no, I don't have that much life in my hands left to do that. So this just measures the Cartesian coordinates and figures out a priority. So this lays up all the cut files. So I'm going to turn on the preview. It's going to run pretty slow now, but there we go. So you can kind of see that pattern repeating there. A little bit better there.
Mhm.
And then let's see. Oh, and because this is really prioritized for the cut files, I've got like different tool paths for different types of angles for the drag knives. And it gives me a little like a heads up of, for an estimator, I can pop out how much material they're using. Let me turn this off one more time, then I'll finish up. The other thing is I get a lot of designs where someone wants to do some weird shallow angle where the baffles all die off. So it's measuring each line, and you can see that reflected here. So each one of those follows that, but it always keeps that pattern going. But yeah, that's kind of shows what I do on like a basic day in, day out kind of thing.
Do you have reason or to mess with the machine that much, or is it pretty well, and you got people who are doing that professionally and you just do this?
I don't. I've kind of set up this weird career where I do like in-house consulting for these companies, and so I'm always working remotely. So I've been working remotely for like 3 or 4 years now, for my second company doing this. So I usually have someone I'll call and just be like, I sent you something, like, tell me like your minimum radius, or let's figure out a way to get it running faster. So one of the things here is like getting those tool paths to end one way and then pick up on the nearest one, because their CAM software is kind of basic. So
It sounds
yeah.
basic. I mean, you know,
Yeah.
just get them some Rhino cam.
Yeah.
I don't work for Rhino, by the way, just so you guys know. Or yeah, McNeil.
Yeah, so I'll just kind of talk to them. The guy who's doing it now it's kind of like one of the owner's brothers, and he picked up, they're like getting used to the tools. So we don't have like, I used to work for a place that had like a very specialist kind of person. So now it's like, tell me what's going on. Let's see if we can make this better, faster, and just work with tolerances, especially when you're working with a squishy material like that. It's like, you've kind of got great tolerances, you know, it's just push it harder. Folding it though, like you've got to get it to a fraction of a millimeter where it folds easily, but it doesn't just split completely. So that's just a bunch of trial and error. So.
And you actually remove material in a V for those folds, right?
Yep. So it's a single the blade is basically just put on a carriage at 45 degrees, runs it one way, rotates, comes back, hits it the other way.
And so, but then you leave that how much web you leave is very important. That's what you
right.
Yeah. Okay. Got
and that's like, I don't know, try 100 runs and let's do that. And then the best ones, try several more times.
Right.
Because if you were to use a V-bit on the CNC router, would that effectively would that melt the foam, or would that cause issues? Is that
matter of their machine right now is pretty basic, so we're getting a Zund that can operate with better tools shortly. So
with
I know
with a router, I think it would get all caught up in the bit.
I can imagine that being a problem with it just catching.
Right.
I think it depends on like the density of the foam that you're working with.
It's not foam, it's felt.
It's felt. Yeah.
Oh, sorry.
Yeah, so there's no like heating element or anything either, so it's just it's just a simple drag knife.
Laser cutting, I mean, felt like wool.
Yeah,
smells terrible.
Oh yeah. I worked with someone.
Not so bad.
I worked with someone who they were trying to do felt jewelry and just always smelled like burnt hair. It was terrible. Plus, I don't know how you do the V cut with the laser.
Yeah.
No. Yeah.
Or you'd have to raster etch it, and that would take a long time. It wouldn't be worth
Be
it.
weird. Yeah.
You
Take
get
a
a
lot
lot
of
of
time.
pilling too, so.
What I really like about that felt is that it is, you know, squishy, and it's a cloth, it's fabric, but it also has a lot of rigidity that you don't expect, and I know better than paper. It's like an origami material. I'm making 3D shapes out of it. You get really cool, soft. You know, they look really great in the light, but you know, you pinch a material in strategic ways, and you can get a really cool pattern out of it.
Yeah.
Um,
The other, so right now I've just got a carriage that does a 45-degree. Like I've worked for places where they'll just machine things to like, you know, like a 72.5-degree, whatever things you want. But the real kind of next level is registering it so you can flip it and do a cut on the backside, so you can cut in 2 directions. So that really comes down to just like being intentional with your layup and like making sure you get the registration cut. But the origami stuff gets a lot more interesting there too.
Yeah.
I was working on a project today where I was just kerfing the back of stuff so I can just bend a radius. So I'm trying to get, someone wants basically 40-foot long runs, and they pretty much want it to look monolithic. And each one's different. So I'm working on all these different radius things that kind of hide their own seams and get stuck together and then kind of slot together.
And
Sounds like
so
a fun project.
do you
Yeah.
use the same sort of grasshopper patches and stuff all through this? Do you just keep adding to it as you need to, or do you have a few that you kind of like a quiver of tools you pull out when you need them?
I've done the opposite. So the one I was showing just now, where I can do like an angled cut, I can do a curved cut, and I can do flat, and I can change the height. I can also actually change the material thickness in there as well, and it updates the cut file. So what I've done there is just like, this is kind of a product type. So I just built everything into like a pull down tab.
Right.
The other stuff, it's usually like a weird new strategy every time of like, how am I going to approach this? So it's usually like, am I making a rectangle and modifying an edge of the rectangle? Or am I making like some other type of geometry and then just like finishing it out as a rectangle in another area later? So those are the things that kind of drive it.
It sort of keeps it fun too, right? I mean, it's always new stuff. Yeah.
Well, all of this is just like every time you do it, you get better at it, or you have a different strategy. So I like just being like, oh, I just took out 10 components because I figured out how to use math.
Yeah.
And then just trying to get better at Python. So there's only so much time.
Yeah, I noticed you had a little script there at the beginning, you know, where your initial inputs after, I forget which one, but
yeah,
I think the XY were the inputs. But no, it's always, yeah.
Yeah, that's a funny one. What the most of those had like a profile at the bottom that undulates to get maximum nesting efficiency. I've got the straight baffles nest better if you drop a part below or above a certain line. So all that does is test to see if you've got something other than a straight line. And then it does a movement and it just says like, okay, nest everything or put everything this way. So when another person nests this for the machine, they get better efficiency.
Yeah, yeah. Okay.
Interesting.
The other people nest the shapes onto the material piece.
Yeah, I let the guy who's operating the machinery just have fun with it at this point. Part of it is they're kind of working on better ways to get the labeling to ride with the project. So I got to make sure 27C goes with 27C a lot of these have two parts that kind of stick together. And it's a little bit of like, it's better for me to push that liability downstream to them so they have control of it there.
Right. Yeah. Otherwise, a lot of coordination for like just tagging millions of things. And
Right. And you can, so the hardware mounts are asymmetrical so that I can set a bias. So it's also like, this has to be rotated and facing this way, not just this order.
Hmm.
So there's a whole bunch of like just little tweaky things.
Mhm.
Try to just, this is the one I just try to bake in as much as possible. And
Mhm. That's pretty cool.
Yeah, cool.
I feel like I had one more. Oh, yeah, I guess I had one thing. There's a guy, I think his name, I feel like he's at MIT, but his name is definitely Joe Lemire, Lamer. But I just keep thinking about, you know, what it is to work with origami in large scale, like ceilings, you know, it's such a, like you will never, you know, ceilings are in a building so powerful, uninterrupted plane, you know, if you can keep your MEP consultants in check.
yeah,
But
we've got a new showroom that's going up in a month, and like there's 100 different baffle companies that are pretty much all doing the same stuff now. So these companies are kind of a dime a dozen. So what I'm trying to do is create like something, instead of just being these linear contours, go into the third dimension. And then I'm working on these kind of pieces that tuck into each other and then seal up the joints so I can make three-dimensional monolithic sculpture that just has like a couple specific cable mounts, and make it look like there's just one pure space noodle. So
space noodle.
yep.
Is that a cousin of the pool noodle?
Actually it is.
Okay. Cool. Cool. Same last name. So
Yeah.
yeah. Cool.
Probably save a lot of money by just hanging pool noodles in the ceiling, but
Yeah, right. Yeah. Very, very unique aesthetic. But
I did an installation that was almost that. It turned out pretty fun, but yeah, it was. I'm trying to remember the name of the baffles, but yeah, there's just large cylinders, and I want to say 4 to 6 inch diameter. They're like oversized pool noodles.
Yeah.
See if I can find a picture of it. Oh, it's on a different computer.
yeah, I also, you know, guilty of working with pool noodles as a building material. But it was actually pool noodles, though. We went to Target. I think we bought, we had to order them online. We needed just hundreds of pool noodles. It was a big project, but it was for what is it? The big swim, the big float. Yeah, when we were doing that way back. But yeah, it took a lot more pool noodles than we expected, but a whole, you know, group of people were staying late at work working on it. And
Did you
fell
take
apart
a
in the
raft?
water. Yeah, it was supposed to be sort of like a group floating vessel. It sort of, I don't know, it was like a funnel shape. We were trying to work
Cool.
with minimal surfaces, or not minimal surfaces. I guess we were trying to just work with these things, these as a material. What we were doing was they were made up of units, you know, circles. These pool noodles just looped together, but each loop or different layers of loops would be different sizes. So you end up getting a shape as things shrink in one direction and then maybe flop into itself. And so it was a fun project. You know, we learned a lot. Pool noodles and duct tape, they don't like each other. Yeah, so yeah, we did so much work, and then later on, I don't know if it got humid or for whatever reason, all the, like, we, you know, think we're almost done, and then everything that we had attached or made circular, then the next day we would turn into the structure, started popping open. Oh no, that one popped. Oh, we'll put more duct tape, and then another one pops, and another one pops, and like everything was just sort of coming undone. It was
It's like in those cartoons when there's water coming out of the wall, and they try and plug it here, and then it comes out, and they're plugging there, and then they get your toes over there.
right. Yeah. At a certain point, it's a systematic problem. We've got to figure out.
Right.
Yeah, let's not put our finger in the dike. Let's step back and think about a whole new thing, a whole new dike.
trying to use expanding foam as a modeling material in grad school.
Oh,
Oh, wow.
It just, whatever you make in a mold, if you can get the mold off, it only hardens on contact with oxygen. So
Oh,
every part that cracks, it just is still liquid and it just jets out and starts hardening again. So yeah, it's pretty,
mhm.
it's a nightmare.
That must have been a fun one-time experience.
Yeah. You go to school to learn, right?
Yeah.
That's right. Yeah.
And you learn most from your mistakes because you'll never forget it.
Yeah, that's how I know so much.
Yeah.
All mistakes.
Uh-huh.
gonna be a genius by the time you get to the end.
Maybe once you understand that about expanding foam, then you can, use that as a feature, sort of as an art piece or
Yeah.
something,
Mm.
Sharon, the program said I fail really well.
Yeah.
I took that as a compliment.
Uh-huh.
I wanted to share real quick what the pool noodle looked like, or the structure out of noodles. Let me. Oop, I'm sharing my screen.
Uh-huh.
Yeah.
Oh, great. Yeah. So here, yeah, this is the mess.
Fruit Loop.
We needed, still PVC sort of structures that this would drape over, but ideally it would have. It looks like I guess like a donut maybe in the water. I also, with the leftover pool noodles, I made a sort of just a cylinder. Oh, and then we also have a bowl. Oh, these were in two pieces at that point. So the outside and then the inside, and then before going in, easy to transport. We had been working on this on the 7th floor of a building, and we had to keep in mind that we would need to take this into the elevator. So that was, I don't know, as a constraint. But eventually it got into the water. But when it got into the water, it started to fall apart. I think everybody, abandoned ship, more or less. It started, I don't know, sort of just hanging on to strangers' boats. But I guess what was probably the coolest was just once it was like done, we sort of abandoned it, and then seeing kids interact with it was maybe the probably the most special part. Like, I don't know, it was really fun, doing this with a whole bunch of people, this silly project, and then going out there and doing it, and then it fails, and you all are like, ah. And then an unexpected sort of like thing comes out of your failure. It's like, oh, kids like it still, so that's awesome. And this was just one, other one of the kids, but it certainly grabbed their attention. So that was the pool noodle. Somehow proud of that project. But sort of hard to, I guess, describe. Or visuals always help, we're visual people.
Well, can I show my little kangaroo thing? Because I actually have to jump here in a few minutes.
Yeah. Sorry if I'm keeping anybody. I just enjoy these so much.
It's fine. I mean, I at least got to go turn the oven on because
okay. All right, please.
There's pizza coming soon. Yeah.
Oh well, yeah. I then hurry. Yeah.
So I can just do this. Let's see.
Let's hope so.
Desktop. You can't do per. I thought you could do per app or something. No, it doesn't.
Oh, like a window. Yeah.
Yeah, I know you can do that with Teams.
Oh, sorry. New computer. I got to give Zoom permission. I got to quit Zoom and I'll be right back. Apparently.
Oh, you got to.
I hadn't given it permission yet to share screen. Sorry. I'll be right back though.
Okay.
So with the big float element, are you with Bora still, or is that way
I'm
back?
not at Bora. Yeah, I just left Bora 3 weeks ago. So I'm a free agent. But that was the big float was, we were working on a design research project that had to do with the Southeast industrial area, what it could be, some visioning.
Yeah.
And that put us in touch with a lot of, people in the community. And one of them was a guy named Ernie, who runs a couple of different swimsuit or swim apparel, beach apparel shops. But he also is like a huge, activist or advocate for the Willamette and cleaning it up and public access. And so by virtue of his work and his group's work, which are the Willamette River Huggers, they host a bunch of events, and then also, go down to the river and clean it up and even like create beaches. We've got
That's really cool.
Yeah, Poets Beach is a really fun one. It's underneath the Markham Bridge on the downtown side.
Yeah.
Yeah,
Okay.
I like that beach a lot.
Yeah, because I was living over there when they just opened up the one over by Hawthorne on the east side.
Right.
Which is cool.
By OMSI.
Yeah. And so I definitely want to get involved with the Winter Lights festival, and then the float. Actually, that sounds really cool too.
Well, it's funny. The float and what we did was not something they were asking for. The Winter Lights, they're asking for like those projects, but this was just like, I'm also like a big fan of what Ernie does, and I guess when I saw Bora engaging him, I was sort of threw myself at it. And it's like, we got to do more. They were engaging him for the design research project, but I knew the big float was coming up and wanted to sort of like, not just engage him on a professional, like we need but also, throw ourselves at it. And
yeah, but I also feel like even if the big float, if that's not what it's about necessarily, is building these kind of fun contraptions that if enough people do it, it can just kind of have a snowball effect and be like, oh, I want to try that next year. And then soon it becomes a fun little part to it all. Yeah.
Okay. Well, GBD, I'll see you at Big Float 2022. I don't know.
Whatever world opens again.
Whenever.
Anyway, Dave.
Sorry, Dave.
No worries. No worries.
Yeah.
We're all here to just have fun. So this, like I said, I used to work for a glass sculptor. And one of the things we did all the time was these big complicated pieces of glass that had to be hung from some ceiling in some building, some big building. These were typically like hotel lobbies in Asia, that kind of stuff. So long ago, we did this kangaroo thing to try to predict how much certain glass structures would droop. He had this way of weaving glass tubes together, like borosilicate tubes, like laboratory tubing, colorless, clear tube. And you weave it together into this kind of fabric, sort of like those mats you use to roll sushi rolls, So it bends one way, but not another, etc. So long ago, we did this kangaroo work to predict the droop of that, and we carefully calibrated it. This time, he just wanted rigid things hanging from a ceiling. So this is kind of the model set up. I hope you can see that. There's little points on the ceiling where we might be able to connect a cable. And then I just, threw some items in. So the Grasshopper thing, let me turn the preview on. Let me turn off the actual Rhino stuff. So now this is the preview from Grasshopper and Kangaroo. And then if I make it go, it does, it drops like that. Yeah. I'll make this bigger for you. One of the cool things it does is it looks at the tensions in the cables and colors them accordingly. So if the cables are tense, then it colors them between green for least tense to red, most tense. And if it's a kind of a slack cable, then it colors it magenta or lavender through white. So I don't know if you can see this, but like this white one, that's a pretty slack cable for sure in this arrangement. This one's pretty slack. That one's pretty slack. This one also looks pretty slack. So theoretically, we could remove those three cables and the positions of these things in space would not change, right? So that's kind of the main idea. How do I get out of full screen here now? What have I done now? Okay, yeah, there it goes again. So now, by the way, I just want to Does anybody else run into this? I'm finding it maddening. The latest version of Grasshopper with Rhino 7 doesn't respect the zoom direction you set in Rhino. Has anybody else run into that? No.
Yeah, I've never adjusted the default.
Okay, yeah, I changed the zoom direction in Rhino all the time because of how I learned or whatever.
Right. Yeah. Yeah. SolidWorks.
And now
or
it's
something.
backwards in Grasshopper. It's absolutely maddening.
Right.
But anyway, so this is, you know, this huge patch, probably a lot bigger than it needs to be.
Oh my goodness, I've seen bigger. Boy.
Oh yeah, there are bigger, but you know, I always want to
Yeah.
like pack it down. It's like you were saying earlier, Nathan. Like, I got rid of 10 components today because I learned something new and used math,
Mhm.
you know, or whatever. Yeah. So I was trying to well, keep it all in a tree structure first of all. I deliberately limited this to, there's not a general case. It only can take up to 3 pieces. Each of those pieces can have cables that go to the building, basically the ceiling in this case. There can also be chain cables between, but piece to piece. But that's it. There can be, piece 1, piece 2, or piece 3, or maybe just piece 1, or piece 1 and 2. And optional chain cables between them, and that's it. I long to do the more general case, but he wanted to stop paying me to work on this, so maybe I'll do it for fun someday. But there's all this, sort of entwining to try to pack up the data to make it work well for Kangaroo. So like, here's all the cables, let me turn this back on. All the cables, all the pieces, which are BREPs, all the chain cables, all the anchor points up on the ceiling, all the centroids of the pieces. And I found that it's actually much speedier to calculate that ahead of time. Anyway, then I finally feed all that into, here's the Kangaroo part. I'm using rigid body, of course, for the BREPs. Lines for the cables, basically what used to be springs, I guess, anchors at the top, and then loads, those are the centroids, sort of gravity, right? Again, go through all this stuff. And now I really had trouble unpacking the output sometimes, because Kangaroo does that thing where it, if it finds 2 points, like 2 different cables have the same endpoint, it just uses one. It throws away the other one. So the tree structure that comes out at the end is not the same as what you put in necessarily. That was a real problem for me, partly because I wanted to. Sorry, go ahead.
Oh, well, I was there's a weird component called show, and it's really, that's like a way of Grasshopper just passing something like unchanged that you can get on the other side. You can isolate maybe something that you want to be affected by Grasshopper, or not Grasshopper, Kangaroo. Something that you want to be affected by Kangaroo, but on the other side of it, it remains accessible in a similar.
Oh, I see.
There it is. Yep. Yeah. Yeah,
and I did something similar here by actually just using 2 solvers. And one of them, see, is there any way to preview this? I'm not sure there is. Those start points.
Yeah, I think you got to hook up.
Get back to here again. Yeah, right.
Yeah.
So start points and out points. There's kind of the shift, and then I go sorting through that basically. And I honestly don't remember the details now. Mm-hmm. I did eventually find the centroids so that I could show them, and that was kind of important to me, mainly because the actual sculpture pieces are really weird, organic, flowy things. So knowing where that centroid is important. So anyway, that's most of it. If you have any questions, let me know. This is the whole display part. There's actually an input slack detector threshold, I called it. And this is sort of a unitless, adjust this till it makes sense sort of slider that is the dividing line between a tight cable and a slack one. The only way to tell cable tension is to look at the length change from before and after too. So that's what I'm doing up here is I look at the length change, from, in and out, and then I split them depending on that slack threshold that's here, and then, spit them out into these gradient display things. So anyway, again,
Slide.
I'm sorry?
The cylinder piece, does that slide down the cable or is it just attached at?
No, it's just that it's only supported, it's not supported well. And I did that on purpose to make sure that things sort of seem to be making physical sense. So there's only one cable attaching it to the ceiling, and the only other cable on it attaches it to this rectangular solid. So as soon as it starts, it falls.
Okay, I was thinking it was like able to slide freely through that. I'm like, that would be complex.
Oh, that would be complex. Yeah. This, this is actually pretty simple use of Grasshopper. What was complicated for me was structuring it all to get into Grasshopper and then unpacking it all at the other end. That was where a lot of the work ended up going.
The slack detector threshold, is that sort of just plugged into all the like weights or strengths of the various components, or?
It goes specifically to this one component here, which is a division component.
Okay.
So let me see if I can.
Oh, and then it's okay.
So I calculate the length changes, right? So here's that. And let me get a box up here so we can look at it. Oh, no, that's not what I want. Sorry. Please hold. I need, because it's a tree structure, I need, what is that? Param viewer, is that what it's called?
Oh, yeah, that tree. Yeah. There it is.
Yeah. Will that help? Now, see, I wanted to actually look at the data. Well, I guess you can.
Well, yeah, I can see that. Yeah, and that one's just 3.
It's there. So these are, very small differences, and this is a deconstructed domain. So this is the end of the domain.
Mm-hmm. Oh, okay. Yep. And then you're setting that up. Does
and I divide it by this threshold, basically. Yeah.
Do you ever have to like reference the Young's modulus and then like cross section length, change in length, and then the Young's modulus?
No, we never did any of that stuff in Grasshopper. And again, this is a while ago. I've been a retired guy now for 6 years, and he just hired me recently to do this little update.
Hey, I don't have a job. Tell him to come to me. I'm just.
Yeah.
You're retired.
We never exactly right. I'll pass along. Yeah. No, we never did that kind of stuff in Grasshopper. Really, that was all sort of spreadsheet stuff. We did test. We did a lot of destructive testing of particular glass structures, like how strong is it, and so we could figure out how safe we had to be to hang the stuff over people's heads. That kind of thing.
Well, as an architect, looking out for the safety and well-being of the public, hanging glass of a indeterminate type sounds scary in a seismically, interesting, unstable.
Yeah, especially in seismic places. Yeah, we did some stuff in San Francisco. That's where the studio was, and some of the stuff in Asia had very strict sort of seismic requirements and et cetera. Yeah.
Right. Yeah. That's really neat.
But anyway, we used Grasshopper mostly, honestly, for extracting information from models that we had already built one way or another. Like, what are all these cable lengths? And then, 300 cables go to certain pieces, and we'd extract all their lengths and make lists of them and export it to Excel and make, to cut all the cables. And, a lot of it was that kind of stuff, extracting information from an existing model rather than generating a model. Yeah.
That's neat. That's really cool.
Yeah. Anyway, it was fun.
Do you have any photos of the finished products or other things
that
this artist maybe has done?
Let me stop the sharing. I should just put the website in the chat is what I'll do.
Cool. Sounds interesting.
Yeah, it's pretty cool stuff. He's not a well-known guy unless you're big in the glass world, or
Yeah.
architectural glass world, actually.
Wish I could say I was, you know. The museum in Seattle is inspiring, but it's like, well,
Yeah.
clients don't want to pay for it. So,
Exactly.
yeah.
So that you see that in the chat, right?
Yeah. Cool.
Yeah, honestly, I haven't been to that website in a while.
Yeah, I've seen photographs of this.
Oh, these are nice. Yeah. Like very, very subtle, or in a way, you know, the colors and.
Yeah, he was always sort of proud of that. Like Chihuly was sort of a bad name around the studio, you know. Oh yeah, he just vomits color everywhere, and you know.
It's like, because you're talking,
This is of course much more refined. Yeah.
you're talking glass chandeliers, and like, I don't know much, but I know what Chihuly is, so I'm glad I didn't speak up yet.
Yeah. No.
Oh,
That's
so he does
fine.
like Chihuly stuff.
I have no problem with it. I'm talking about what the real glass people thought, you know, and a lot of these people were graduates of what was it, CCAC, California College of Arts and Crafts,
Yeah.
across the bay. Yeah.
Yeah.
And he hired me because I was an engineer.
That's really nice work, though. I really like that stuff.
It honestly was a really fun job for a long time. There was a lot of I got to wear many hats because it was a small studio, and then honestly, that's just fun. Yeah.
Neat.
All right. Unfortunately, I think I have to bail.
That's all right. I really appreciate you.
Thanks very much. It's lovely. It's lovely to talk about this stuff with people that
Yeah.
actually understand it. You know, because there aren't many.
Yeah. Well, we're gonna have to ask you to present sometime. It looks like you understand something about data trees, and we were talking about, you know, maybe
A little. Yeah.
learning something about it. But
I want to get better. As a matter of fact, I started another version of this this thing with a different tree structure. I thought it would just be better because right now it's each piece is a branch of a tree, but then that list, it has all the information for the piece, is in a particular order that you have to know. So I thought it'd be better if that was branches. So then now it's a 3-layer tree, and then I started getting lost. So
yeah. I really like there's the path mapper. Have you been playing with that?
yeah, I've played with it in the past, and I did
Okay.
flirt with it recently again.
That's where the magic happens.
Yeah,
Or-
absolutely. Right.
Yeah.
Yeah. And there's another
Love
one.
that.
What was it? There's another one I learned about. Well, I spent a lot more time with Entwine than I ever had before recently. Yeah.
Sure.
And when Merge, just plain old Merge worked for a lot of things. Anyway.
Yeah, absolutely.
What
Cool.
Okay.
I was working on
Well,
one
anyway.
time, you can like just break up the text itself and just like start parsing out each thing and reassembling. It's like the most laborious way to do it, but
Right.
I backed myself into a corner one day and I was just like, all right, let's just
It's
put
the way
this
out.
here, put this there.
Right. You know, and I have a feeling this whole section I showed you where I'm packing up the data and arranging the trees and stuff, it seems like that could all be replaced with one little, you know, Python module if I just spend the time to do it.
But then it's always, you know, the inputs need to be stable also, and that's maybe still is volatile or whatever, or at least that's
Right.
always what happens to me. I do something that I think is going to be like, I'll never have to touch this again, you know, and then
It's
first
never
slider
true.
I touch, it's like red. Yeah. So
Exactly.
okay.
All right.
Cool.
Well, thank you again for this. That was really fun.
Yeah, I
Thanks,
really
Dave.
enjoyed it. Thank you, Dave.
Okay. See you next time.
See ya.
Enjoy your pizza.
Yeah. Bye.
Andy, would you like to, or do you have something to share? I can share something.
I certainly can, and then I probably need to drop off and go do
Okay,
that
yeah.
dinner thing.
Sure.
Basically, I'll do one small component real quick, and it's more of where we're at right now is trying to present and convince everyone else that this is something valuable and a worthwhile endeavor to invest the time into, you know, learning some new software, learning new workflow approach, all of that sort of thing. So
Mm.
it's really been more of, I don't have, I think, a dozen or so smaller demos to try and show people, okay, this is how you do this one thing. This is how you apply it to other things. And then we have one project that I don't think I'm able to show. So I'll play on this on the safe side, because it's
Right.
still,
I'll just assume it's Nike. You just
but it's, one of those, it's new enough, and I'm not sure how the client feels, but that has been kind of a showcase where, okay, how do you end up doing, how do you apply all of these different things? And so you have, this curved roof form, and controlling just the upper edges, and everything else is linked, and most of that was just record history. It wasn't even Grasshopper. But then how do you slice that up and give it structure? How do you do structural arrays across something that isn't rectilinear and differing heights because of the roof? And then do a gradient array with the facade treatment with alternating elements. And I think I can pull that up. But anyway, it's just, here's like this one project that then has, I don't know, 6 or 7 different components applied to it. And I'll try and let me find this other one real quick. So I'll just show you two things real quick, and neither of them are incredibly complex or like really something to write home about, but it is more of deliberately trying to keep things a little more approachable for people, because that was one of the parts. Okay, how do you present this information to someone who has never seen Grasshopper before, let alone understands how it's set up or what it does? And like that balance of, can you wow them without scaring them?
No.
Yeah.
You can't. No, and I mean, if you do it at GPD, please tell me how you did it. Or
Okay.
at least I struggled with it, I guess. And there would always be, if somebody didn't come to the firm with a comfortable with Rhino and Grasshopper already, it was so hard to get them to just move the slider. It's like,
yeah. And that is something that, I was kind of thinking about, is that, okay, you don't need to know how all this stuff went together in order to get the benefit from using it. And that, that tiered approach of there are going to be people that want to do this, and there's going to be people that don't. And
the people that don't need to know how to do it and just need to know how to do it. And I think with Rhino inside Revit, they'll realize finally what they've been missing.
Yeah. So this one is dealing with the gradient array for the facade. And I'm trying to remember if, well, I'm just going to try and delete these other parts, just kind of simplify things down a little bit. But the idea was, okay, we have this just a really simple bar of, it's metal, it's wood, we don't know yet. And if you are able to alternate it and then stack it, that then you start getting this kind of woven appearance, that when it's straight on, it just reads linear. And then as you start to get more of a glancing angle, you get that weave pattern happening throughout. And so then this was just a matter of playing with how dense, I guess, the array occurs, and then how long that happens, which is all pretty straightforward. But then the aspect of getting the alternating components made it a little more dynamic and interesting and fun to try and solve. So as far as learning about graph mapping and pulling out alternating variables, is okay, I want to evaluate the number in the order of which it happens, not the numerical value of the object itself. And just being able to show people like, hey, you can go through those design iterations instantaneously, because if you have, and again, in the actual model, this is stacked up, I think 4 or 5 tall. So you could adjust the gradient and how far that stretches across the building. You can do it on the fly. Like, I don't know, that looks good, and move on to the next, versus to do those level of iterations by hand. The time wasted is just ridiculous. And knowing that no matter what you do, it's never going to be right the first time. There's always going to be someone else, higher up the food chain, whether it's in-house or the client. I'm like, well, but what does this look like? Or can I have that? And you're like, okay, yeah, I'll go back and spend, the rest of my afternoon getting you this thing that doesn't really matter, but you just got to see it, versus being able to, do it on the fly and not only save time, but your sanity as well.
Sometimes it's good to like, I don't know, like have them sort of step back and try to have them, I don't know, describe to you what the parameters are specifically that they would like to control, rather than you guessing. Because I've often had the experience that is, designer will come and ask for something. They don't really know what they're asking for, I guess, sometimes. Like, I just want to, I don't know, mess with this small thing, and then they realize, like, once they start messing with that, they want all the parameters. But I guess asking them what the parameters are that they're interested in beforehand helps to limit your scope, and you can deliver something without feeling bad for it. Like, this is what you asked me to do.
Yeah, because too often, like, someone asks for something and it seems questionable. Like, you go back to them, like, okay, why do you want that? And they explain it, like, oh, that's not actually what you want. What you really want is this other thing.
Yeah.
And I mean, there's a story I remember hearing about how some fabricator was trying to make whatever parts that were given to him on the drawings, and one of them was a square hole in the part, and he's trying to figure out, like, okay, how do you actually do that? That's really complicated. And finally he just walks downstairs, goes across the campus to the other building to where the draftsmen were, like, why do you actually want this? Like, oh, well, it doesn't really matter, so I just drew a square, because drawing the square was easier than drawing the circle. And this is doing things by hand or whatever, not even thinking through the process and how much of a nightmare that could have been if you just followed the instructions, versus, do you really need this?
Right. Yeah. Being sort of being able to be explicit and implicit, or being able to, I don't know, define that, I guess, anyway, to somebody else.
A lot of the convincing I end up doing of, like, why we should do Grasshopper or not is, a lot of times people have a concept, and it usually is like, what if the GC calls you and says those 8 inches you thought you had, you don't have? How do we change this rapidly? Or, like, if you've got some sort of something that's a pattern and you need to change it, are you going to scale it? Are you going to scale it 1 dimension? Are you going to drop off members and keep those the same? Do you want to scale the space between them? So you think it's just like, oh, I've got something that's X dimensions and I need to just get it to some other dimensions. But, like, anytime you're working with a pattern, there's 5 different ways that translates.
Yeah.
So usually I'll just, like, start with someone else's thing, give them a problem, and then just be like, how are you going to solve this? And then that's where I find the Grasshopper is most useful, because it kind of bakes in a logic too. Like, let's make a decision of what that transformation is going to be.
But that with great power, or being the one who's making these for other people to use, it's like you got to anticipate all their needs, and then the moment you missed one, now maybe it's just about adding it, but most often it's like, I got to redo everything now because I got to insert this thing way over here.
Yeah, it depends on your audience too. Sometimes it's just like you just make it for yourself to get through a job, and sometimes it's like, I need to hand this off to someone who's only ever going to slide something.
Yeah. I gotta say, I appreciate that you even have people willing to slide. So, yeah.
I'm trying
Not that, yeah, not to speak bad, my coworkers, but yeah. Sorry, Andy.
That's right. That's right. I figured actually I'd jump in with one other thing. Just as far as like you're saying, being able to make those small adjustments. And so the reason I dropped this one together real quick was because I was talking to someone else about a different example, and then like, oh, so well, what about something like the Telecom Bridge and doing the cable stay, having all those things connected. And I was like, oh yeah, no problem. And so I did a real rough 2D thing, and then was able to build that on the fly while we were chatting, and then decided to develop something a little bit further. And how all of this is really based off of this one magenta line, that if I grab these 2 control points and pull them over, the rest of it's all mirrored and offset and all those other things, but also that this the curve of the cables is based off of that offset as well. And we might not be doing bridges, but being able to have that, talking through the mental approach to doing these things, where all of a sudden I can do this very quick mock-up to get it to the client because they always want it yesterday, and then they change their mind, so you got to come back and change it, and then you get more information from civil, structural, whomever, and saying, okay, you have, I don't know, 8 cables drawn, but in reality you're going to need 12 or 13. It's like, all right, well, I'll just change that. And then someone else says, okay, the way you're anchoring it, you're not going to have enough concrete between your points, so you actually got to spread those out a little bit more. And so you can, that's the cable diameter. Like, okay, so I'll do that. And being able to start very quickly and then evolve and refine as you have time and are given more information, versus rebuilding and redoing your work, which I think is just a huge issue with the industry, of how much time is sunk redoing things that don't need to be redone. And it eats away your opportunity for any sort of design time, because you have to do the technical stuff in order to get the project finished and built. So that's non-optional. And so the thing that gets on the cutting block is design.
A good exercise would be ADA regulations. Set those as like boundaries. Be a good
yeah
intern project.
Oh, do you think it's an intern project? Well,
you can use it all the time.
So with Revit, Rhino inside of Revit, yeah, you can take all the rooms, take their floor plate, figure out where the exits are, and automate a code plan pretty easily, which would be awesome.
Yeah, that'd be cool.
But I don't think an intern could do that. But
someone studying for the ARES and integrate all that into use that as a learn Grasshopper, but also create a really great reference guide for themselves.
Mm-hmm. That's typically how I learn things. I feel like is either I'm making maybe a definition to try and understand sort of the logic or system, or making a picture, to try and make a diagram or simplify it.
Have you guys ever integrated with structural engineers where you're giving them stuff that you generated in Grasshopper and then have them analyze it? What's the kind of trades interaction there?
We haven't, but it's something we're certainly looking into, because my colleague who's working on this effort with me he's more sustainability and analytics side of things, and being able to look at the data and performance and be able to ideally feed that back into and get design adjustments accordingly, and speaking with other trades and consultants, and it's like, hey, you guys should really be using this. This is where you have the benefit. And so structural, being able to do those analyses, and especially when you start getting into kind of strange, atypical And for this example here, roof structure, that I'll get rid of that. Well, so I guess real quick, that the idea that this can be applied to any sort of planes, whether it's curved or straight or angled or tapered or whatever. When I just tried applying it right there, and the planes are inverted, and it's gonna take a minute to fix. But okay, where do I, oh, it's because it's over here.
Weaverbird has some good tools to like control or correct, you know, the UV space of a surface. As far as like getting the right orientation for stuff like this.
Okay.
Yeah.
I'll have to play with that one. But again, this was because the building we were working on, as far as just rough design, was a curvature roof in both axes and varying thickness throughout. So like, okay, how do you actually then cut a section through there and populate structure? And so this was the demo piece, as far as, okay, you can have, well, the highlights in yellow, so it's a little hard to see, but you can have whatever plane you want. And if you actually have control points with this one, or how did I do that? Okay, well,
maybe it's the view template, or, you know, rendering doesn't show any curves or points or whatever. I'm not sure.
Otherwise, I can also just, you know, I can move it up, and it auto connects and populates. And then, you know, the structural, this is just, you know, super rough to get the conversation in a facsimile, have something rendered, you know, whatever for the client. But then you kick it over to structural engineer and something like, oh yeah, no, your spacing's way off. And so I think this is going to lag a little bit because of the preview display. And because I dropped it down way too far.
Nice. Never going to fall down.
We'll just put that back to, yeah. So the idea, like, you can change your spacing, you can change the number of divisions, and then of course, you know, being able to show them, hey, you get this weird little kink right here, so maybe you change it so that it's where'd it go? Issue on the odds. So if you can,
yeah.
Why is it not doing what I want it to do?
Weird.
Oh, because I played it wrong. Anyway, and then making sure that there's also an offset built into the radius, so that, because this is all built from running a contour across two planes, and then everything's based off of that. So if you were to do a pipe around that contour, your structure would actually be clipping through the ceiling and through the roof. So try to just take some of those other considerations in mind. And at this point, it's a very light, simple script, and then being able to have control over the spacing between the trusses, the number of divisions, and then how big your members are. And like, that's it. This can be applied to absolutely any building you want to have some sort of truss component for. It's built once. You don't have to worry about it again. You can apply it to whatever and just off and run.
Yeah, I can imagine you could make the member size a function of like some imaginary dead load, and you could slide whatever you think your roof calculations are, and then it would just automatically scale the members.
Yeah,
that'd be cool.
Or be able to integrate, you know, just span to depth ratios for certain things. And like, what's nice is that you can take what's here and just, it works, but you can always make it better. And okay, I'm going to add another layer of not even complexity, but just another layer of information and make it, you know, harder, better, stronger, faster, whatever. And and that time is never wasted because you can keep using it. You copy and paste the relationships, but it's completely adapting to your particular criteria and circumstances.
Yeah. What is this hole for?
Yeah.
Right. It'd be cool to be able to, I don't know, sort of somehow tie in what's actually maybe possible with these open web joists. I really like the way this looks. And from what I understand, it is actually pretty easy. Any sort of truss is pretty easy to construct. It's hard to just.
Yeah, so that was the other thing, is I started trying to do that by hand, and it was one of those things where you're just getting, tons of spaghetti and did a little digging and not too much. And Lunchbox has a component where like it's all packed in there. You give it the top curve, bottom curve, and there you go.
Oh, that's actually interesting. I was wondering about that because you were talking about top curve, bottom curve, and lofting something and being able to just sort of host everything onto that surface. But more so outside of the computer, like how are they actually going to build this? Like the bottom chord and top chord are going to be of different dimensions. They're going to be rectangular. They're probably going to be sandwiched together, if there's going to be like an aluminum strut between the two, and starting to actually, tie. I know you said this at the beginning that it was an example, but now I'm asking for everything that you.
Yeah. No, that's okay.
In the future.
Because it's this sort of thing where it works in this respect here, but yeah, you need to take it to those next steps and those next levels of, is this actually a pipe, or is it square, or is it angle iron, and can you actually do that correctly with your as an extrusion, or rebuild things to be a little more accurate, time permitting.
Right. Yeah, I love the whole structural industry because they've standardized everything, and that's really helpful because then you can just have like a value list or a list of options, shapes, and whatever.
And just last thing real quick, and then I'll stop. But the reality was this was going to be more of actually what the building might have been doing as far as the roof structure, something strange like this. And when I was talking through this with somebody, it was fun to be able to kind of just talk on the fly and say, okay, well, let's say you make some adjustments that there's no reason why it needs to be vertical, but then also you could set multiple curves, and now all of a sudden you're getting
space frame,
and again, being able to just kind of tweak things on the fly as you need it to meet whatever objective, and you don't have to stop because the tool is set up one way and like that's all you get. But instead you can well, what if I do this? What if I do that? Maybe I want to see this other approach, and just being able to explore all those various outlets is pretty great. And being able to hopefully show people and them get it.
Have you ever had the opportunity to show this in front of a client?
As far as like the Grasshopper side of things?
Yeah, like we're considering this. These are some options, like.
Oh, just like do the sliders right in front of them.
Right. Yeah. Like, what about this?
Yeah, not yet. But because we're still in the early phases of kind of getting this adopted, and the one other project has, they saw the results in the rendering, but not the live meeting where we'll work through some things. But I have certainly considered that and am looking forward to that opportunity and just again getting the right client for it and just totally blow their mind with what's capable. Because I also don't want to show everyone because like, oh, you can do things that quick that
Mhm.
obviously then okay, I'm going to ask you for something and you can do it in 5 minutes instead of a day, and now your timeline has changed.
Yeah, that maybe in light of that comment that you've anticipated, yeah, that it may be a problem. That was sort of why I was like, it's really sort of important to talk to designers and figure out what do you really want. Like trying to, okay, we have a problem, we have resources, we have constraints, we have, I don't know, a timeline and costs and whatever. We have parameters and we have a thing, and let's sort of be specific about defining the scope and the design space that they would want to see, which is design space meaning what combination of parameters do you want to see together. And that, I guess, has been really helpful because otherwise you will be working on the same project or the same, like, I don't know, it starts to get real messy. Or my experience has been, it's been really messy when your designer sort of like, make some.
Yeah.
You go nuts and everything they want is not what you did. It's like, well, you told me to make something.
So I unfortunately need to jet and do the dinner
Sure.
thing and feed the kid. But
Yeah.
certainly enjoyed hanging out with you guys and just kind of talking through some of this stuff.
Yeah, it's cool. We're all the only person in our business doing it.
Yeah.
Jacob, you're running solo, but
You know, I knew I wasn't the only one that and so
There are
I'm
dozens
happy.
of us.
yeah, all across Portland and Beaverton, outlying area. Yeah, so it's nice that we can come together. Real quick before you run next meeting, do you guys got any suggestions? Show and tell was good. I almost want to just keep doing that. It was really fascinating just to like see how many extensions people have and see how they're just sort of the way that they're setting up definitions, you know, like working left to right, working up and down. Dan had like a cool, he's like nesting things together, very nice and compact, very visually. All that to say, the show and tell was very fun. I don't know, what do you guys have any other sort of like thoughts or things that you would like to get out of all this, or maybe what will we do next month?
I do not have a specific or anything that I'd be interested in. Might be too specific, perhaps. But I think the show and tell is, I think it's a good like alternating, you know, every other meeting, giving people time to, depending on what they're working on, time to develop things. Otherwise, I might just be like, oh, that's the same thing I had last time. Yeah, no, I'll try and think through some stuff, because for me right now, I'm more interested in the learning and seeing what other people are up to, and trying to.
I wish I had, you know, time or to show you what I was working on, because I think a lot of it was addressing designers and making them use my program to do the things that they want, and making it easy for them, and it's a trick. The definite, I actually uploaded a video today on YouTube. I'm going through my portfolio, so I'm very much looking at things that I've done.
Because if you wanted to show a bunch of stuff next time, since you didn't get an opportunity today, I think that.
I always am afraid that I'm going. Yeah, I always fear. I'm afraid of those. Yeah, because I could just talk endlessly. I could just leave no space for anybody else. So, but I it would be cool to show something. So maybe I just go ahead and just show something. You know, work. Actually, you. I guess having your critique on my work would be awesome. So
sure.
That would be really cool. All right, next month. Yeah, it's a critique. Yeah.
Sounds good.
All right.
'Cause, yeah. Otherwise, I'm trying to dig into the Rhino inside Revit, and if you know a bunch of stuff and want to share, or if I can figure something out, I can relay. And I'm really regretting I missed the sub D chat previous. So if you want to ever go back to that or I'm all ears.
Yeah, that one's recorded, and I've been trying to upload them on YouTube. I just haven't been able to get the contents of my work computer yet.
Gotcha.
So, yeah, but they promised me that they would give them to me, so, the files. We'll see. But yeah, I definitely have the video of that. It was really good. It was, yeah, it's nice to just hear somebody sort of just walk you through the threshold into a new tool or technology. So,
Yeah.
Cool.
All right, well, thanks a lot.
Thanks,
Thank
guys.
you.
Have a
Yeah.
wonderful evening.
Yeah. You too.
See you next
Bye
time.
all.
Bye.